actually going to work on algebra tiles right now. How many of you have used algebra tiles in a classroom already? Could you share some of your experiences?
I think sometimes teachers, I think kids would definitely see this, but teachers are timid to using these because that's not how they were taught. I mean, we kind of had that discussion before. And if they would just take the time to work through the task like this, like we're doing,
Yes.
and really see how it fits together, then I think it'd be a lot easier to teach the students how to do it. I think there's just a disconnect between how we were taught and how we would like our kids to see it.
One of the connections that I think the high school teachers could benefit from is realizing that kids have used base 10 blocks in the same way with algebra tiles, and so they can make that connection that they may feel more comfortable using them in their classroom at the high school level, because the kids do have some prior knowledge of how to do multiplication.
We talked earlier about students being visual learners for the most part.
Yes.
And so for students to be able to see what we're trying to do with actual equations or functions, then I think it's easier for them to make that transition.
Kids do better than we expect them to do. And it takes it's the fear of just trying it because it's not familiar for us, but to give them a chance. And I've learned a lot from the kids when they are doing this.
Even if it didn't work beautifully when we were multiplying, and it did work. But when we started factoring and they were going backwards, the connection was really unbelievable because they could see it multiplying to get what was inside and taking what was inside and going backwards and getting the factors. So I thought that was great.
Which is really the meaning of factoring. It's not that we gave our kids an algorithm to follow. They were figuring out what factoring means. This is so powerful for their learning.
Well, and it also takes kids from the concrete where they can touch this thing and make it real to the abstraction where they could draw and represent, and then to the true abstraction when we use symbols to manipulate. So we're going to take that trajectory, tie it from the concrete to the representation, then to the abstract, as opposed to going right to that abstraction, which makes perfect sense to us because that's the way we learned it.
Yes,
However,
again,
they missed that boat.
you can actually feel it and touch it. This is that concrete experience that takes them to abstract and in that meaningful flow of learning where they can actually build and understand it. We're building a bridge between algebra and geometry, really, because algebraic understanding here is going to be grounded in geometric representation. So really, we're integrating math, which makes sense.
I also think teachers need to know that this is not something that they're going to use every single day throughout completing the square. We eventually want them to get to that point.
Right.
This may be just a small piece, and then you're going to, at least have them available for kids that still don't understand. But it's not going to take 2 weeks to just work with algebra tiles.
Right, and it's a scaffolding piece, right? And the students will discover through completing a square with tiles why we divide b by 2, why we then square it, right? And then we can offer it as a differentiation tool.
Kids have had that experience. It's just a matter of the high school and the middle and the elementary having that vertical dialogue to tie it together.
Let's just go ahead and work through some of the activities with algebra tiles. Before we do that, I would like to show you some things that I sort of put together, discovered over the past few years. I feel like this is what students need to know, be able to do before they get to high school, before they do algebra tiles in high school. They really need to understand that equal sign means balance. Really, really understand that. You know, how many times do they say, whatever you do to one side, do to the other, and then you go, why? And then they go, because my teacher told me to, right? Equal sign means balance. Another thing that's very helpful is for students to know dimensions of tiles. And I mean not just the representations, but the dimensions such as, this is an x by x. This is x by 1, which represents, of course, an x. This is 1 by 1, which represents a positive 1. And of course, we use red tiles to represent negatives. We really need these dimensions, I feel like, when we multiply and factor. We need to know additive inverse. The students may have seen this in middle school as 0 pair. So when they see that combination, of course, they can just remove the tiles from the group because the value of this is simply 0. And it's not an absence of a number, right? It's a value, and the value is 0. Negative sign. I feel like this is such an important part of math. We really need to get our kids to understand that negative sign means the opposite of. Because when they subtract polynomial expressions, when they add an x squared, they simply add this tile to the group. But if they subtract a positive x squared, negative sign means the opposite of. That means you actually flip the tile with your hand upside down. This is what distributing -1 means. This is what they can touch and feel. So they actually have to flip each tile physically when they perform a subtraction of polynomials. I believe that this is a really big part of their understanding how to subtract polynomials. How many of them actually forget? This is the very usually missed question on an assessment, subtraction of polynomials. But what if we give our kids hands-on experiences where they can actually physically flip the tiles every time they see a negative? What if that might help? And I found that this interesting verbiage, share equally, which comes from elementary school, for sure. Has to be either probably first grade. Yeah, so I think this really helps with solving equations. And if we use that vocabulary that students are familiar with, because if we know their prior knowledge, when we teach new concepts, we can build that connection. And some of you had mentioned that earlier today. This is something I have kind of put together. This is just me. It may or may not be, sufficient, but I feel like these are the skills that students need when they come to high school. And if they don't have them, we need to start here to make sure they're prepared to do multiplication, to do factoring, and completing the square.